Hi all. So let's talk acid-base reactions, right? So acid-base reactions, typically in chemistry, there are a lot of titrations. There are other types of acid-base reactions, but generally we talk titrations. Okay. So real quick, an acid, as we've defined so far, is something that has an H with it. There are other definitions of acids, but in general, acids have an H. So binary acids have the H and then another nonmetal. Oxyacids, polyatomic acids have the H and then whatever that polyatomic ion is. So in general, acids have an H attached to them. Okay, there are other types of acids that do not, but for the purpose of this class, let's go with that. Okay, there are three types of definitions of acids. We're going to focus on the first two, Arrhenius's definition and then Bronsted-Lowry's definition. Arrhenius says, hey, an acid produces H. When it's dissolved in water, it gives you an H. So for example, HCl dissociates to give you H plus and Cl minus. Arrhenius then said, hey, well, for a base, it has to give you OH minus. Okay, so NaOH dissociates to give you Na plus and OH minus. Holistic definition and doesn't cover every single acid and base. And so Bronsted-Lowry is a better definition of acids and bases, captures a lot more acids and bases. They're what we call Lewis acids and bases. We're not going to cover that in this class, but that is an even broader cap or definition for acids and bases. So the Bronsted-Lowry definition is one that we prefer. And it essentially says, hey, an acid is anything that's going to donate a proton, and a base is anything that's going to accept a proton, which is a hydrogen. Okay, so and if it donates a hydrogen, it's an acid. If it accepts a hydrogen, it's a base. And so in this case, when HCl combines with water, it donates a hydrogen to water to give H3O plus, which is the hydronium ion, and the chloride ion. On the flip side, when NH3 combines with water, it accepts a proton to give you NH4 plus, the ammonium ion, and the hydroxide ion. So you'll see that with this definition, we're still seeing OH minus and H plus in there, but it just is a broader definition. Okay, here are some characteristics of acids and bases. You can read this, so I'm not going to read it to you, but the big thing here, acids have pHs less than 7, bases have pHs greater than 7, and then a neutral pH is equal to 7. Big idea here is just kind of looking on the molecular level, on the molecular scale, on how acids donate protons in water. Okay, so for example, here, H can donate, this H can be donated, technically this H maybe too, but donate an H in solution to give you the hydronium or the hydrogen ion. So you'll see these used interchangeably. They're essentially the same. The H3O plus just indicates that it's in water. And when we figure out the molarity of that, that's where we get pH from. We're not going to talk about pH in this class or how to calculate it, but that's kind of where pH comes from. It's the amount of hydrogen ions in solution. Okay, again, acids typically we write with H first. Acetic acid is an acid, but that is written with the H at the bottom, at the back of it. But yeah. So let's talk about electrolytes, right? So we've talked about electrolytes, and electrolyte is something that is that ionizes in solution, so breaks up into ions. And acids, we talked about acids being something that breaks up into ions, right? Acids and bases will break up into ions. There are two types of acids, strong acids and weak acids. Strong acids will ionize completely, so they break up into ions completely. That direct arrow shows that. Weak acids, on the other hand, do not. So this kind of intermediate arrow, two-headed arrow going, I guess, back and forth, shows that, hey, there's some of the acid remaining as an acid, and then some of it breaks apart. So the big idea here is strong versus weak acids. Strong acids break up completely or ionize completely in solution to give you all ions, while weak acids, you're going to have some of the acid or some of the molecule left, but you're also going to have some ions. Okay, so they don't dissociate completely. So in terms of ions in solution, strong acids has mostly ions in solution. Weak acid has mostly that molecule in solution. So the acid molecule in solution. Some ions, but mostly the acid molecule. And so because of this, we can talk about strong versus weak electrolyte. We've talked about this in a different place, but the big idea here is because strong acids break up completely into solution, we consider them strong electrolytes. And weak acids do not, and so these are termed weak electrolytes. Okay, so weak acids don't break up completely, and so we have very few ions, so there isn't as much electricity conducted. Strong acids break up completely, and so we have a lot of electricity, a lot of electrolytes. It's a strong electrolyte. Okay, all right. There are 7 strong acids. You are responsible for them. Here are they. Here they are. Okay, those are the strong acids: HCl, HBr, HI, H2SO4, HNO3, HClO3, and HClO4. You need to know those. If it's an acid and it's not on the strong acid list, it's a weak acid. Okay, so memorize the strong acids. If it's not on the strong acid list, we consider it a weak acid. And so just kind of thinking about how these things dissociate, this is how, or yeah, ionized in solution, that's how HCl would react with water, chloric acid, and so on. On the flip side, bases, again, also react with water, but they accept protons instead of donating, okay? So NH3 would react with water to give you the ammonium ion, so it accepts a hydrogen, and gives you OH minus in solution, okay? Just as you have strong bases and weak bases, we also have strong acids and weak acids. You also have strong bases and weak bases. A strong base ionizes completely, so it breaks up completely into its ions, shown by that arrow. A weak base, on the other hand, is at equilibrium. So you have some of the base, but then also some ions, okay? Strong base, considered a strong electrolyte because it breaks up completely, for the most part, into ions. A weak base would be a weak electrolyte because there's only a little bit that breaks up. Okay, the same holds true for strong acids and strong bases, strong acids and weak acids. So for strong bases, you need to also memorize them. These are group 1 and group 2 elements that combine with hydroxide. So Li is a group 1, Na, K, all group 1. Group 2s, there are exceptions, but for the purpose of this class, if it is a group 1 element that combines with hydroxide or a group 2 element that combines with hydroxide, you can consider it a strong base. Anything else would not be considered a strong base. So FeOH2, this is a transition element. Iron, this is a weak base, okay? If I tell you this amine is a base, you assume it's a weak base, okay? So anything that isn't a group 1 and a group 2, so group 1 and 2 plus OH would be strong. Anything else is considered a weak base. Okay, so again, we talked about pH. I'm not going to test you on this, but you will be seeing pH in other classes. The big idea here is, hey, how acidic or basic is something is based on the pH. And so I talked about earlier, the pH greater than 7 is a base, less than 7 is an acid, 7 is neutral. Okay, so pH, hydrogen ion concentration, it just tells you how much H plus is in there. Okay, so hopefully that gives you kind of an overview of acids and bases. On the next video, I'll talk a little bit more about doing math with acid-base titration. Okay, and that's it.